Okay, here's section 7.1, a title that you're hopefully familiar with, at least maybe in words, maybe you don't remember the whole theorem, but Pythagorean theorem, named after Pythagoras. If you're talking about the Pythagorean theorem, I showed you too much, you have to have a few things. Number one, it has to be a right triangle. If it's not a right triangle, the Pythagorean theorem doesn't work. So if you draw a right triangle, it has a right angle symbol or a 90-degree angle symbol in it. Parts of a right triangle, it has two legs and a hypotenuse. So if I go with this drawing, I'm going to label this A, B, and C. Notice capital letters for the vertices. But then little a will be across from capital A, little b will be across from capital B, and little c will be across from capital C for the sides. So the two legs of the triangles of any right triangle are A and B in this case, or you could say it's the two sides that make up the right angle. The hypotenuse would be C in this case, or it's always, you could describe it, it's always the longest side. It's always the side that's opposite the triangle from the right angle. But if you can't identify the two legs and the hypotenuse, then you're not going to be able to do the Pythagorean theorem. Pythagorean theorem. This may come back to you. A squared plus b squared equals c squared. And these are all lowercase. The side squared plus the side squared equals the hypotenuse squared. The two legs, order doesn't matter. It's addition. Commutative property works. Hypotenuse matters. You have to put the long side in the C. Okay, so if you have a problem like this, go ahead and pause it if you need to. Take the time to draw it. You identify that 5 and 12 are the legs and that x is the hypotenuse. We're going to solve for x. So we'll go a squared plus b squared equals c squared. Now here's my preference. I don't know how often you hear this from a math teacher, but I don't want you to show your work. I don't want you to write down that 5 squared plus 12 squared and write down 25 squared is 25. Then write down 12 squared is 144. I don't want you to do that because in all my years, I see way too many mental mistakes. And if you're going to do the work, you might as well do it right? You might as well do it more quickly. A mental mistake, like somebody will write down 5 squared is 10 and 12 squared is 100. Or they write 12 squared is 144. Or they write 12 squared is 24. 144 would be fine. But what I prefer that you do when you're doing your work is just take 5 squared plus 12 squared and get 169. So preferably this gets calculated so that there are no mental errors and you just go straight from 5 squared plus 12 squared to 169. That's x squared. You know from your triangle inequalities that we worked on in a previous chapter that you can't have a side of 5, a side of 12, and then a side of 169. It would never make a complete triangle. Square root is the inverse of a square. It gets rid of it, but whatever you do to one side of the equation, you must also do to the other side, and you find out that the x is 13. So this would be called, because they're all whole numbers, a 5, 12, 13 triangle. That's a Pythagorean triple. When they're all whole numbers, you call it a triple. It's a 5, 12, 13 triple. Okay, not always are you going to be given the triangle. Sometimes you're just going to be told what the sides are if they tell you what A, B, and C are. This time we know A and C, but we don't know B. So we're going to go A squared, 7 squared, plus x squared equals 14 squared. Again, I would really, really, really prefer that you use a calculator. What I would like you to do is minus 7 squared from both sides. Could you turn that into 49? Could you turn that into 196? You could, but I'm guessing that most of you are going to take 196 minus 49 on a calculator anyway. So it's quicker and faster to just minus 7 squared to both sides. The issue is You can't take 14 minus 7 is 7 squared and your answer is 49. That does not work. You have to actually take 14 squared minus 7 squared and get 147. X squared equals 147. Square root both sides. Square root of x squared is gone. Square root of 147. The issue with that is that if I try to square root 147, it is irrational. You can't write the answer. You would not write this answer unless you were looking for a real life answer. You wouldn't put 12.1 unless it was a true to life problem, real world problem. So what we have to do instead is simplify our radical. 147, I think 7 goes into 147, and it does 21 times. 21 can break down into 7 and 3. I have a pair of 7s, which means my b, my x, is 7 square root of 3. Once you know how to break radicals down, you're going to be expected to always break down radicals. Let's try this one. We have 1, 2, and x. No, it's not 1, 2, 3. We'll have to do a squared plus b squared equals c squared. 1 squared plus 2 squared equals x squared. 1 squared plus 2 squared is 5. And if you square root both sides, x is the square root of 5. Square root of 5 cannot be simplified, so we leave it as is. Blank 8 and 10, we have x 8 and 10. We know that x is a squared, b squared, c squared. Again, we're solving for x squared, so you're going to have to minus 8 squared from both sides. 10 squared minus 8 squared is 36. Again, should I say this again? It's not 10 minus 8 squared. It's 10 squared minus 8 squared. Square root both sides, you find out that x equals 6. Another Pythagorean triple. Any Pythagorean triple is if you have 3 numbers that fit the Pythagorean theorem and they're all whole numbers. So 6, 8, 10 is a Pythagorean triple. That is not a Pythagorean triple. This is not a Pythagorean triple. 5, 12, 13 is a Pythagorean triple. Okay, let's try this one. 4x and 8. X is in the b. So we have a squared plus b squared equals c squared. Minus 4 squared from both sides. You get x squared equals, might as well double check. I was going to say 48. I should have. But always double check. X squared equals 48. Square root both sides. We need to break that down into a couple of factors. I don't know which ones. You could use 16 and 3, 12 and 4, 8 and 6. I have a pair of 4s, so I know that that's 4 square root of 3. If you check your answer, let's work with both of those. If you're checking your answer to see if you got it right, you could take 6 squared plus 8 squared and make sure that you get 100, which is 10 squared. If a squared plus b squared equals c squared, you're fine. Be careful when you check your answer on 4 square root of 3 and 8, that you do 4 squared plus parentheses 4 square root of 3 double parentheses. If you have a calculator like mine, my calculator gives you a parenthesis at the square root, so parenthesis, you need them doubled. What is 4 squared plus 4 squared of 3 squared? It's 64. What is 8 squared? It's 64. So you can check your answers and make sure you got them right. A little foreshadowing earlier. I told you that there's going to be some Pythagorean triples. Any 3 whole numbers that fit the Pythagorean theorem, which means we could work out 3 whole numbers that fit in the Pythagorean theorem to infinity, There's a list that never, ever ends. And believe it or not, some people do that. They just keep looking for more and more Pythagorean triples. Some of the most common triples, 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. All of these fit a squared plus b squared equals c squared. A squared plus b squared equals c squared. And you could take those lists, I mean that's just 5 of them, of the most common ones, and you could double them. A 6, 8, 10 would work. A 10, 24, 26 would work. A 14, 48, 50 works. You could triple them. This could be a 9, 12, 15. These are the basics, but any multiple of those would work also. If you don't believe me, check it. What's 9 squared plus 12 squared? Bet you it comes out to 225, which is what 15 squared is. You could multiply them by 10. You could have a 30, 40, 50 Pythagorean theorem. You could have an 80, 150, 170 Pythagorean triple. So all you need, okay, it does not have to be on this list. This list is infinitely long. I can't give you the whole list because it never ends. How do you know if it's a triple or not? All 3 of them are whole numbers. Oops, I was supposed to circle that. All 3 of them are whole numbers. And you can't say, oh, then I'm going to use 1, 2, and 3. Well, that doesn't work because 1 squared plus 2 squared is 5, not 3. So it has to be fit a Pythagorean theorem and all be whole numbers. Okay, so we're going to expect that you know how to use the Pythagorean theorem in these problems and combine it with, do you know how to find the area of a triangle? Just a friendly reminder, area of a triangle, you have to take half of its base times its height. So, we need a height. Base and height are always perpendicular to each other. 7 is not the height of this triangle. If base and height have to always be perpendicular to each other, we need to cut that in half and make it perpendicular. This is 5, this is 5. We don't know how tall this is, but we do know the hypotenuse of that 90-degree angle we just made. So we can do the Pythagorean theorem, 5 squared plus h squared, because we're looking for the height, equals 7 squared. What is 7 squared minus 5 squared? You get h squared equals 24. Read the instructions before you go too far. It wants us to go to the nearest 10th. You could square root this, and you could take the time to break down 24 and do factor trees until you get all the way down to 2 squared is 6, but you might as well not because it wants a decimal anyway. So your height is the square root of 24. Come back over here and plug it into the formula. Area equals 1/2 times the base, which was 10, times the height, which is square root of 24. And if you want to know what works in math and physics and chemistry and all the other science and math classes that you take, you do not round this answer to the nearest 10th first, then plug it into the formula, then end up rounding it again. Rounding happens at the end of the problem. You may have a bunch of different decimals, and you will, coming up shortly. Stay tuned for chapter 7. You only put it in once. So we're going to take half of 10, which we already know is 5, and the square root of 24 times the square root of 24. Half of 10 times the square root of 24 is 54.49, or no, not 54, 24.49, which rounds up to 24.5. So you're expected to know area and the Pythagorean theorem. Find the area of this one. Go ahead and pause it. Take the time to draw this. This is what I think is funny. I guess it's not funny to make fun of students, or to feel bad for them, is they hear the word base and they think bottom. Half the base times the height. The base is often the bottom of a lot of things, but not always. Base and height, the only thing true about base and height is that they have to be perpendicular to each other on a triangle. Doesn't say it has to be on the bottom. So I watch people try to draw a height here, But then they don't know how big this base is, or they'll do the Pythagorean theorem to try to find this base. But then it's like, but I don't know the height because this wasn't divided evenly, and it becomes a very, very difficult problem. When in reality, you already have 1/2 times the base times the height. Pythagorean theorem is not necessary. You could just turn your triangle, if you like it to be at the bottom, put it at the bottom. But it's not. It's like, how did I have that? I don't know. 1/2 the base times the height. Oh, I had it crooked. I know, I remember. It was like this. 1/2 of 10 times 60 is 30. Work smarter, not harder. Think through things before you set them up. All right, good luck with your Pythagorean theorems and your areas.